Hey everybody, welcome to 6.1. We're going to be dealing with polygons. We're in chapter 6. Chapter 6. Welcome to chapter 6. Okay, so we got done with triangles, triangle congruence. Now what we're going to be dealing with is primarily polygons. And today we're going to be classifying polygons, just like the first day of our triangle chapter, we classified our triangles. This time we're going to classify and identify polygons. That wonderful thing, polygons. Find angle, and we're going to be finding angles of quadrilaterals. All right. So the very first thing I want you to do is I want you to write this down. Write that first section right here. Okay, well, of what a polygon is, and then I do want you to draw a few examples of polygons and maybe a few examples of not polygons. So pause now and draw those shapes. All right, now when you look at this, what is a polygon? A polygon is defined as a closed plane figure formed by three or more line segments. Okay, so we're going to have three or more line segments, and do notice that all of them are closed and they're not curved. Okay, so if you look at this shape down in the not polygons, see how this side has that curve appeal to it. It's not a straight line. It's not a line segment. All right, that's a curved line, and that's what makes it not a polygon. Also notice that triangles are polygons. Okay, no, that's just a three-sided polygon. Okay, and it goes on from there. Any shape that has a straight line and straight sides and it's closed are going to be polygons. Okay, notice this shape on the right side here is not a polygon because it connects and it crosses over. Okay, because this line crosses this line, okay, that makes it not a polygon. Now, if you broke those apart at that point and broke them right here, that would be a polygon, but because they cross over, it is not going to be a polygon. All right? Awesome. Okay, so I do want you to write this down. It says, each segment that forms a polygon is a side of the polygon. The common endpoint of two sides is the vertex of a polygon. Then, we're going to deal with this a little bit later, but a segment that connects any two non-consecutive, notice it's non-consecutive vertices, is a diagonal. So if you look at this shape below, all right, make sure you draw that shape with the diagonals and with the labels there. Okay, as I explained this, if I start at point B or the vertice B, okay, the first non-consecutive vertice, I can't go to A and I can't go to C because they are consecutive. They're right next to each other. So I have to draw a vertical from B to D. And then another vertical, or not a vertical, sorry, a diagonal. Another diagonal would be from B to E. So this would have two diagonals in this shape. Now, what kind of shape is it? That's what we're going to figure out right now. This would be a five-sided polygon, which means, if you haven't finished, pause. I'm going to move to the next slide. Which means this shape would be a pentagon. If you look at this, it's going to be, that shape would have been a pentagon. Okay, what I want you to do is I want you to write this down. Yes, I do want you to write that chart down on the right and write the thing down on the left. Notice it is all underneath that beautiful yellow bar. Then I will talk about this. Okay, so pause now. All right, so if we look at polygons labeled by its side, okay, so triangles, of course, are going to be three sides. Quadrilaterals are going to be four. Pentagons, five, and so on and so forth. However, notice if you looked back at that previous example, the one that you had in your notes, okay, that's not a perfect. It is a pentagon, but we know pentagons that look like this. Okay, just because it does not look like this does not mean it's a pentagon. Okay, a pentagon is any five-sided shape. Any five-sided shape. Okay, so they don't have to be, we'll get into this later, regular polygons, okay, or a regular pentagon. But as long as it has five sides, it would be a pentagon. As long as, if you look at 9 sides, if it has 9 sides, it's a nonagon. If you look at the very bottom, okay, if you get larger, so if it says, notice it does say n-agon, so if I give you a shape that has 15 sides, okay, so a beautiful shape that has 15 sides, that would be known as a 15-agon. Okay, it's just a 15-agon. I know it sounds weird, but just if it has more than 12 sides, label it as a 15-agon. Okay, or label it as however many sides it does. Okay, so moving on, I'm going to label. So using that list that you just wrote down and writing these problems and these shapes down, make sure, tell me whether the figure is a polygon, and if it is a polygon, name it by the number of sides. Okay? If it is not a polygon, I want you to explain your reasoning. So pause now, give this one a shot. All right, so this first one, if you look at all of its sides, it has 1, 2, 3, 4, 5, 6. Okay, because it has 6 sides and they are all straight, that is going to be what's known as a hexagon. Hexagon, because it has 6 straight and they're all closed sides. Okay, it's formed by 6 segments and it is in a closed plane. Okay, next one is going to be that arrow one down below. We count the sides. 1, 2, 3, 4, 5, 6, 7. This one has 7 sides. So what shape do we know has 7 sides? That's going to be a heptagon. Heptagon. Okay, last one. We have that beautiful crescent moon. It has 1, 2 sides. Okay, so now, is this a shape, or sorry, is this a polygon? No, and there's 2 reasons why. It is not a polygon because, first of all, it does not have 3 sides. Doesn't have 3 sides. But it also has curved lines. Notice that line here from point, let's just call this A and let's call this B. From point A to point B, all lines are going to be curved. Okay, so it doesn't have 3 sides and has curved line segments. Okay, so that's 2 ways. All right, awesome. Okay, we are going to be moving on to the quadrilateral interior angles theorem. So please write this down and then I will explain. Okay, write this down. I will explain. So, when you look at this quadrilateral interior angles theorem, that says the sum of the measures of the interior angles, remember interior meaning inside, the interior angles of a quadrilateral is 360. If you added up all those angles, it would equal 360. The reason behind that, okay, if I go and I make a diagonal on a quadrilateral, so I'm looking at this quadrilateral ABCD, I'm going to make a diagonal from D to B. Notice, this is 2 triangles. Okay, essentially it's 180 degrees here, total 180 degrees here. When added together, it's going to be 360. So, because of that, the interior angles theorem, quadrilateral interior angles theorem, if you add up A, B, C, and D, it will always equal 360. Okay, so let's try a couple of problems. Remember this. Okay, so if we look at this next one, it says find the value or values of the missing angles. Okay, so these are 2 quadrilaterals. I want you to give these 2 a shot and pause. All right, so let's see how you did. If I look at this, all right, I look at this very first one. I have an 80-degree angle, a 75-degree angle, 105-degree angle. That's 75 plus 105 plus x. What do they all equal if I add them all up? That is going to equal 360. So when I do this problem, I look at 80, 75, and 105, and I add those up and I get 260. Plus x is equal to 360. Okay, from here, one-step problem, subtract from both sides. And what is my x going to be? X is going to be 100. However, it is an angle. What do we need when we have an angle? We need our degrees symbol. 100 degrees. Perfect. Hopefully you got 100 degrees. Okay, same idea with this next quadrilateral. Notice it has 3x on both sides, x on the other two angles. So 3x on two angles, x on the other angles. Remember, adding them all up, you get 360, because that's the which theorem? Yes, it is the quadrilateral's interior angles theorem. Okay, so now you get 3x plus x plus 3x plus x equals 360. Okay, now when you do that, you now have 8x is equal to 360. And when we take 8x is equal to 360, we need to divide by 8. Divide by 8. Divide by 8. 360 divided by 8 is going to be 45. So x equals 45. Now, notice we just found x is equal to 45. So these two angles right here are 45 degrees. We are not done though. Okay, because we need to also find these angle measures. Okay, so then we take 3x, which is when x is 45, 3 times 45, and 3 times 45 is going to be what? 135. That's what it is. Bingo, bango, bongo. We're done. Okay, we are finished with 6.1. I hope you are as excited as I am to get into polygons. Woohoo! Okay, so I'm going to hand you your homework, and you will be able to work on it. Have a great day. Hand you the homework later, not right now. Okay, have a great day. Yeah, polygons.